Okay, Jai Hind. So today we will discuss the subject theory of automata and formal languages, and subject code is KCS 402. Okay. So today topic is push down automata. In the previous lecture we have discussed push down automata introduction, and we construct some PDA for some of the basic language. In this lecture we construct PDA for some more language. Okay. So let's see some recap that what we have done in the previous lecture. That we know that regular language is accepted by the finite automata. Okay, we have covered this. Okay, finite automata. Okay, in order to accept CFL, we required machine. That machine is PDA. Okay, that machine is PDA, and PDA is similar to finite automata with some extra memory. Okay, with some extra memory, and that extra memory is called stack, and this will helps the PDA to recognize CFL. So in short, we can say that PDA is finite automata plus one stack, and this stack is memory element. Okay, that we have discussed in the last lecture. Okay, and we have seen the graphical representation of PDA, that there is input tape, finite control, and there is stack. Okay, push and pop operation we perform. There is one reading head which moves only in one direction, and this PDA accept and reject the language. Okay, gen node is the initial bottom of the stack symbol. We have seen all these tuples, that Q is the set of state, sigma is the initial input alphabet, tau is the stack symbol, Q node initial state, gen node is the bottom of the stack, delta is the transition function, and F is the set of final state. So we have seen the language acceptance by PDA by acceptance by final state, and language acceptance by empty stack also. So let's construct some more language for the and construct the PDA for these language. Okay. So here construct the PDA over sigma equal to a comma b for the language a raised to power n, b raised to power n, c raised to power n. So see here, there is comparison between a raised to power n and b raised to power n only. Okay, there is no comparison between c raised to power n, because here power is m, here power is n. So how we construct the PDA? First we push n number of a's, then corresponding to that a, when b comes, we pop out the a. Okay. Now when all a will over, then all b will over, it means a raised to power n, b raised to power n. C can be na. So we skip C. So what I can say, that suppose there is language a raised to power 2, b raised to power 2, and c raised to power 1. Okay, how we construct the PDA for that? So a, b, b, and c. First a will came, top of the stack is z node, so we push a. Next a will came, top of the stack is a, we push a. When b will came, top of the stack is a, so corresponding to b we pop the a, so we pop that a. Now next b will came into the picture, and top of the stack is a, again we pop this a. Now a and b are over. Okay, and stack is we reach at the final state. Okay, so this a raised to power n, b raised to power n will be satisfied. This c, there will be no comparison, so we skip this c. Okay, so how we construct the PDA for that language? So there is state Q node. Okay, when input is a, top of the stack is z node, we push a z node. When input is a, top of the stack is a, we push A, okay, we push A, okay. When input is A, top of the stack is A, we push A. When input is B, top of the stack is A, we pop A. So this is the pop operation. Now I am at state Q1. At Q1, when input is B, top of the stack is A, we pop A. So these are the pop operation and these are the push operation. Okay. Now we keep on doing this. Now when input is C, top of the stack is Z node, we skip the Z node, we skip the C. Okay. So we remains Z node as it is. Okay. Now when input is C, top of the stack is Z node, we keep on skip the C. When all C will be over, when input is epsilon, means their string is over, top of the stack is Z node, we keep Z node as it is and we reach at the final state. We will reach at the final state. So these, let's see, these are the push operation. These are the push operation. This is the pop operation. This is also pop operation. This is the skip operation. This is also skip operation. When input is Z epsilon, top of the stack is Z node, we keep at Z node. This is also skip operation, and this is the final state. Okay, so this is acceptance by final state. There is state Q2. Okay, so this is the required PDA for the language A raised to power n, B raised to power n, and C raised to power m. Okay, so next see the third for next example. Okay, construct the PDA over sigma equal to A comma B such that language A raised to power n, B raised to power n, C raised to power n. So here comparison is in between these A raised to power n and C raised to power n. There is no comparison between A raised to power n, B raised to power n. Okay. So what we will do, simply we simply skip B. Okay. When A comes, we keep on pushing A. When B comes, we skip B. When C came, corresponding to 1C, we pop out 1A. When all C will be over, then in the stack, either there will be Z node, then this is language acceptance by final state, and if we pop out Z also, then this is language acceptance by empty stack. Okay. So let's see, suppose there is language A, B and C. There is stack Z node. When A is the input, top of the stack is Z node, we push A. When A is input, top of the stack is A, we push A. When B is the input, then we simply skip. We simply skip this B. Okay. Now when C is the input, top of the stack is A, we pop this A. When C is the input, top of the stack is A, we pop A. Now my stack is only contain Z node. So we reach at the final state. So let's construct the PDA for that. Okay. Now here I am state Q node. Okay. Now when input is A, top of the stack is Z node, we push A Z node. Okay, when input is A, top of the stack is A, we push A. Okay, so we push all the A's till now. Now when input is B, and top of the stack is A, we keep it as A only. Okay, we only skip. So here all the push operation will be performed. Here all the push operation will be performed. Here when input is B, top of the stack is A, we skip. Okay, then this is the skip operation, we skip. Okay, now I'm at state Q1. Okay, when input is B, top of the stack is A, we keep on skip. Okay, now next, when C is the input, okay, now all B's are over. Till now we assume that all B's are over. Now when C is the input and top of the stack is A, we pop A. Corresponding to 1C, we pop 1A. Okay, so this is also the skip operation, and this is pop operation. This is pop operation. Now I am at state Q2. Now when there is C, top of the stack is A, we keep on popping. We keep on pop A. Okay. Now all C's and A's are over. Okay, it means string is over. Now when input is epsilon, top of the stack is Z node, we keep on at Z node, and we will reach at the final state. Okay, so this is language acceptance by, this PDA is language acceptance by final state. Language acceptance by final state. Okay, this is language acceptance by final state. Okay, when A is the input, top of the stack is Z node, we keep on pushing. A is the input, top of the stack is A, push AA. When B comes, we skip. When all B's came, we skip all the B's. When C came, we pop 1A corresponding to 1C, and we keep on popping. When all the string element will be over, then input is epsilon, top of the stack is Z node, and keep it as Z node, and we reach at the final state. Okay, so this is the PDA for the language A raised to power n, B raised to power n, C raised to power n. Okay, see the next example. Okay, that A raised to power m plus n is equal to B raised to power m and C raised to power m, means number of A is equal to number of B and number of C. What it means that number of A is equal to number of B plus number of C. So how we will construct the PDA for that? When A comes, we keep on pushing A into the stack. When all A will be over, when B comes, we pop A. We keep on popping A. When C comes and top of the stack A contains A, then again we start popping A. It means when after pushing all the A's and comparing with B and C, all A will be pushed 1-to-1 correspondence, then this language will be accepted. Okay, So let's see. So I am at state Q node. I am at state Q node. Input is A. Top of the stack is Z node. We keep on pushing A. Input is A. Top of the stack is A. Push A. Okay. Now when we push all the A's till now, so this is the push operation. Till now we have performed all the push operation. Now when B is the input and top of the stack is A, we keep on popping A. Okay. Now I reach at state Q1. Now input is B, top of the stack is A, we pop A. Okay. Input is B, top of the stack is A, we pop A. So this is pop operation. This is also pop operation. Okay. Now now all B's are over corresponding to A. Now C is the input and top of the stack is A. Again perform the pop operation. And I will reach at state Q2. Again pop the element corresponding to A, C. Okay. Now again C is the input, top of the stack is A, pop the element. Okay. So here there is pop operation. Now till now corresponding to number of A and B, all A will be over. So input is epsilon, top of the stack is Z node. We keep Z node as it is and we will reach at the final state. So this is the final PDA for the given language. Okay. Fine. So this is the language acceptance. By final state. This is the language acceptance by final state. Okay. Language acceptance by final state. Right. Now construct the PDA for the given language, that A raised to power n equal to B raised to power m plus n, and it is C raised to power n. Now there is comparison. Okay. So there is comparison between A raised to power n and C raised to power n. Okay. Okay, fine. I think fine, this is also fine. We construct the PDA for that. Here number of A equal to number of C and it is B raised to power m plus n. There is no relation. Okay, it is similar to this example. Okay. So okay, we will change this one, that A raised to power m, B raised to power m plus n and C raised to power n. It means number of A and C equal to number of B. Okay, number of A and C equal to number of B. So how we will construct the PDA for that? I am at state Q node. When input is A, top of the stack is Z node, we push A. Input is A, top of the stack is A, we push A. Okay, we push all the A. Now corresponding to B, when B is the input, top of the stack is A, we pop. Okay, we pop A. Now I am state Q1. Now input is B, top of the stack is A, we keep on popping A. Till now till now all A's are over, all A will be popped off, but B still not over. Now input is A, B, top of the stack is Z node, we push B Z node. Okay, now again pushing B, now input is B, top of the stack is B, we keep on pushing B. Now all A are will be popped off corresponding to B. Now some B's are still there. Now we push all these B. Okay, now C will come. C is the input. Okay, top of the stack is B, we pop. Okay, B. Now I'm state at Q2, input is C, top of the stack is B, we pop B. Okay, now input is over, top of the stack is Z node, we keep Z node as it is and we accept the language. Okay, this is the PDF to the language A raised to power m, B raised to power m plus n, C raised to power n. Okay, thank you.